Hi there, I'm Miss McGee. I'm going to be teaching you about game theory, which is module 4 in AP Micro. Module 4 is where we deal with the product markets that are the imperfectly competitive product markets. There are 3 imperfect competition product markets, and game theory has to do with the oligopoly market. Okay. So I'm going to show you what to do when you have a game theory matrix put in front of you, how you work it out, how you isolate the variables, how you figure out the dominant strategies, and how you figure out Nash equilibrium. We're going to look at the bottom matrix down here. And whenever you are given a matrix, you'll also be given like a write-up. And the write-up is going to tell you what the scenario is and what's happening. Here with Greyhound and Orange Tiger, these are 2 bus lines that are having to choose between whether or not to give an early departure or a late departure, a late time departure. So those are the 2 choices. You'll notice that Greyhound has early and late right in front of it. That's our left hand player. And Orange Tiger is our top player, and they are going to be the columns. Okay, so one thing to remember is the player on the left is going to be referring to the rows, and the scenario for the player on the top is going to be the columns. So that's one thing to kind of keep in mind and remember. So the very first thing that I'm going to do is I'm going to assign each of those numbers to a player. Remember that the player on the left is always the first number in every box. So again, the player on the left is always the first number in every single box. So I'm going to put a G to the left of the first number in every single box because those are my G numbers. The player on the top is always going to be the second number in every single box. So I'm going to put an O to the right of my second number, indicating that those are my Orange Tiger numbers. So that's the first thing that I'm going to do when I'm working on a game theory problem. Now I'm going to look at the dominant strategies. In order to look at the dominant strategies, you need to look at a given player's scenario. And in that player's scenario, what is the other person deciding to do? Remember that the Greyhound scenarios are the rows, the Orange Tiger scenarios are the columns. That is one big place where people get really messed up and they flip it around and they don't do it the right way. That's a lot of reason why people get wrong answers on game theory problems, is because they're doing Orange Tiger as the first number and Greyhound as the second number, or they will do both sets, both players as rows, or both players as the columns. You've got to do one scenario doing the rows across and one scenario doing the columns going down. And let me show you what I mean. So if we're figuring out a dominant strategy for Greyhound, you're going to look at the Orange Tiger scenarios, remember the columns, and look at what the Greyhound decisions are in the Orange Tiger scenarios. So what do I mean by that? The best way, especially visually, in order to understand what you're doing here, is to block off what we're talking about. When Orange Tiger is choosing an early departure, that is the left-hand early column for Orange Tiger. This is the Orange Tiger early scenario. We're going to look at our G numbers and figure out, well, what is G going to do? Greyhound is going to choose 500 because 500 is better profit than the 375. So I'm going to put a box or a circle around that 500. Then I'm going to look at the Orange Tiger late strategy. When Orange Tiger is choosing a late departure, Greyhound, the better Greyhound number between 475 and 350 is $475. So I'm going to put a square around 475. Those are the choices that Greyhound is choosing when Orange Tiger is making their choices. So now I'm going to get rid of my box and I'm going to look at the Greyhound decisions. Again, remembering that Greyhound are the rows. So they are going to choose early for one scenario and for the $500. Okay. In another scenario, they chose early also for 475. You don't have any G late numbers. 375 and 350 are not circled or squared. So Greyhound is never going to choose a late departure no matter what Orange Tiger does. This is a dominant strategy. That means that they're going to choose early departure no matter what they do. And so their dominant strategy is early. Now, when I'm going to look at the Orange Tiger decision and dominant strategy, I'm going to look at the Greyhound scenarios, which are the rows, and I'm going to look at the Orange Tiger decisions in the Greyhound scenarios, which are the rows. So before I looked at the columns, now I'm going to look at the rows because now I'm looking at the Greyhound scenarios. Again, this is another place where people have a tendency to mess up and it screws them up because they go back to looking at the columns again. And you're not looking at the columns, you're looking at the rows. So when Greyhound chooses an early departure, the top early row, the better O number is 425. 425 is better than 400. So I'm going to circle 425. Then when Greyhound chooses a late departure, which is the bottom late row, the better O number, don't get thrown off because we don't have G's circled here. The better O number, which are our second number in every single box, is going to be 400. 400 is better than that 325. So now I'm going to look at the Orange Tiger decisions. Orange Tiger, remembering my columns, is not going to choose early at all. They're going to choose late for 425. They're going to choose late for 400. They do not do any of their early column decisions. So they're never going to go early, and they're going to have a dominant strategy for late. And that's what I do. I write the early and the late so that way when I'm going down to the FRQ questions, I'm easily able to answer when they ask me whose dominant strategy is what. There might be a question that will say, does Greyhound have a dominant strategy for late? Well, if you worked it out and you're looking, no, Greyhound doesn't have a dominant strategy for late. They've got a dominant strategy for early. And you can explain why using the numbers in the chart. The last thing, and this is the part that baffles everyone, they always have a very difficult time understanding why Nash equilibrium happens or how to come up with Nash equilibrium. I'm going to explain it the really easy way, and then I'm going to explain it the more difficult way, or just the reasoning behind it. Okay. So Nash equilibrium is simply the one that has both of the numbers circled. So when you are looking at this matrix, it's going to be this top right box. That's the Nash equilibrium. That is the one that has both of the numbers circled in that box. Now, the complicated explanation for some people, that's complicated, okay, that we know that Greyhound is going to have a dominant strategy for early. We know that they are going to. We also know that Orange Tiger has a dominant strategy for late. So because we know that Greyhound has a dominant strategy for early, we know they're going to choose early. And that means that when they choose early, Orange Tiger is choosing late. Now, in this situation, we have two dominant strategies, which is not fully common. You don't always have this kind of example. Oftentimes you have one dominant strategy and then one that doesn't have a dominant strategy. But this just shows you that example of what that would look like. This is the choice that they are definitely going to make. Greyhound is going to choose an early departure for 475, and Orange Tiger is going to choose a late departure for 425. And that would be that Nash equilibrium. But again, the easy way of remembering, it's simply the box that has both of the numbers circled. Sometimes you will have a question and you'll have two Nash equilibriums. And that would be where we would have this 475, 425. But then let's say we had 375, 325 and down in the bottom left-hand corner circled. And those were the other numbers that were circled. That would be a 2 Nash equilibrium problem. And that is possible. It's definitely possible that we could have that. Okay. Hopefully this helped you in understanding how to work out a game theory matrix, how to go and answer those questions. I will make a follow-up to this with additional problems so that way you guys can feel comfortable with that. Feel free to reach out to me to get those practice problems that I've got. You can also just Google, AP micro game theory problems and come up with a plethora of them to practice this strategy and get all the way through to that Nash equilibrium. I wish you the best of luck on your AP and good luck in game theory.